We're going to be doing this question over here where we are given an identity cos of alpha minus beta, which is equals to cos of alpha cos of beta plus sine of alpha times sine of beta. We need to use this identity, and then the question says that we need to use the given identity to derive a formula for cos of alpha plus beta. Notice that this one over here has a minus in between alpha and beta, while this one has a plus in between alpha and beta, but then both of them are within the trig ratio cos. Right, so we must use this idea over here, cos of alpha minus beta, in order to derive this one. So because we require a plus over here, right, we require a plus, what we're going to do is that we're going to say cos of alpha minus beta. This minus times this minus takes us to a plus, right? But then also what it allows us to do is that it allows us to use this identity over here, because we have a minus in between these two, alpha and the minus beta. We have a minus in between them, so it allows us to use that particular theorem, right? Let me just cancel this so that I can write them properly. So it's going to be alpha minus beta. So let me close this minus beta so that, so now hopefully it's closed nicely so that there's no confusion. Let me just write it over here. Right. Okay, cool. So now remember, we are given that cos of alpha minus beta, but then in this case our beta is this minus beta over here, is equal to cos of alpha cos of beta plus, which means that this positive negative sign changes to a positive sign, sine alpha sine beta. So we're going to have cos of alpha, but then we're going to have cos of minus beta, and then instead of the minus we write the plus. Then we're going to have sine of alpha multiplied by the sine of minus beta. So now remember also that in terms of the negative angle, a negative angle is in the fourth quadrant, right? And then also, just for information's sake, theta minus 90 is also the fourth quadrant. The first quadrant is theta minus 360. The third quadrant is theta minus 180. Second quadrant is minus theta minus 180. Right. And then now in this first quadrant, all of them are positive. In the fourth quadrant, cos is the only one positive. In the third quadrant, tan is the only one positive. In the second quadrant rather, sine is the only one positive. So notice that when we have a negative angle, we're implying that we're in the fourth quadrant, right? Okay, cool. Now let's get into it even further. So implying that this one over here is going to be cos of alpha, then cos of minus beta. Because we're in the fourth quadrant, this is going to remain as cos of beta, positive. And then plus, we have sine of alpha. Now sine of minus beta, remember that minus beta is in the fourth quadrant. Sine is negative in that quadrant, so it's going to be minus sine of beta. Simplifying this even further, cos of alpha cos of beta. This plus sine alpha multiplies the minus sine beta. We end up with minus sine alpha sine beta. And then we have proven, or rather we have derived, because if you recall, this would be cos of alpha plus beta, because the negative multiplies the negative. So implying that cos of alpha plus beta would be cos of alpha cos beta minus sine of alpha sine beta. So we've actually derived the formula for cos of alpha plus beta from the formula of cos of alpha minus beta.